So welcome to section 4.7. So far we've been doing a lot of stuff with derivatives, and now we're going to do antiderivatives. So that's what goes backwards, right? Because they say you don't know anything until you know it forward and backwards. So here's our definition. A function f is called an antiderivative of lowercase f on an interval I if f prime of x equals f of x for all x and I. As with any definition, sometimes they're kind of hard to parse through, but kind of as an example, if we look at f of x and it is, let's just say 2x cubed, ah, 2x cubed, and if little f is 6x squared, then the capital F is the antiderivative. F of x is the antiderivative. Oh, good God. Of little f of x, since f prime of x is equal to 6x squared, which happens to equal the lowercase f of x. So that is all it means to be an antiderivative. So let's see if we can, find a few or whatever. Now, what would the antiderivative of, so you might see wording and stuff like that, find f of x if f prime of x is equal to 4x to the 6th. Okay, so if that's the case, all you got to do is remember your basic differentiation rules, and we're just going to go backwards, or some of the things you might need to have memorized. But like if you were to take a derivative of a polynomial, you just got to use the power rules and stuff, right? So what would you do? To take a derivative, you take the exponent and you multiply it by the coefficient, and then you subtract 1 from the exponent, right? So you multiply the coefficient by the exponent, and then you subtract 1 from the exponent, right? Now we want to do that backwards, so we're going to add 1 to the exponent. Okay. So we're going to add 1 to the exponent, and then we're going to take the exponent and divide the coefficient. So we start off with 4, so we're going to do 4 divided by 7. And that gets us an antiderivative. Now, is that the only antiderivative for that? And it turns out the answer is no, because the derivative of any constant is 0, right? So we could have a plus 1 here, or we might have 4/7 x to the 7th plus 123, okay? Or maybe 4/7 x to the 7th plus pi, okay? Any of those are antiderivatives for 4x to the 6th. So what happens is an antiderivative actually gives us what we call kind of a family of functions, and all they are is they're all just translations. So, the basic one might go through the origin, and it's going to look like this. The next one, we just raise it up 1 or raise it up 2 or down here or whatever. But you get the same function. It's just shifted up and down depending on what that constant is. So when we talk about the general antiderivative, okay, so a general rule antiderivative, what we're going to do is we're going to throw a plus c on the end of it, okay? And that's always going to work that way. So again, let's just do a different one. If f prime of x is, let's just say sine of x, then what would f of x be? Okay, so what function gives you the derivative sine of x? And that would be negative cosine of x. Because remember, when you do the derivative for cosine, you have to do a negative, right? So that negative will cancel out with the negative I just put down there, but we have to tack on this plus c. Do not forget to do this when it asks for an antiderivative. You have to have the plus c on there, otherwise it's not quite correct. What if we have, now just as a little notational thing, just practice some various stuff. So let's suppose that f of x equals 2 over x to the 4th. What is the antiderivative? So what is the antiderivative for this function? Now, it doesn't have to say it's f prime. It's just you get a function, and then you ask for the antiderivative. You want to find, well, the antiderivative for that. So I would still think about this one as the power rule, and that is 2x to the negative 4th, right? So the antiderivative, which I'm going to call capital F, just to match that definition that we had earlier, is what we add 1 to the exponent. So that's going to be a negative 3, okay? Because we take that plus 1 gives us negative 3, right? Then we divide by that new exponent. So this would be a negative 2/3 x to the negative 3rd. Okay, we could write it like this, but we got to tack on that plus c. What about, oh, before I get to that one, we do one other here. What if our function we want the antiderivative of is f of x to the 1 over x? So if it's to the 1 over x and we try that power rule, and we think of it this way, then when we add to the exponent, we're going to get a 0, and then we would try to divide by that, we get 1 over 0, which is undefined, right? So keep in mind, what function has 1 over x as its derivative? So if you think back, the antiderivative for that would just be the natural log of x, and you might be real tempted to put that, and it would be actually slightly wrong. Okay. Natural log of x, if you think about the graph, remember is, looks something like that, right? Well, 1 over x is defined on the negatives as well, okay, not just the positives. So in order to deal with that, then the derivative that we want, we just put an absolute value sign here. So the derivative for 1 over x, the antiderivative for 1 over x, is the natural log of the absolute value of x. Okay? Because on any of these negatives, we need to change those to positives in order to be able to evaluate it, right? So those little absolute value signs, important. Okay? Don't forget those. So other little harder examples. So let's say this is our derivative. We know g prime is this. Let's find out what g is. So on something like this, I would do my best to rewrite it so I don't have rational functions if I can. So if I reduce this, that's going to be 2x to the 4th minus x to the negative 1/2. Okay? This piece right here, because remember you have to divide them both, think about that as x to the 1/2 over x, and our rule is subtract the exponents when we're simplifying that stuff, right? So 1/2 minus 1 would be the negative 1/2. Now it's a little bit easier to do our antiderivative. Okay, so that's going to be negative 4 cosine of x plus, and then we'll have x to the 5th, add 1 to that exponent, divide. So it's going to be 2/5 x to the 5th. And then we're going to have minus, and then we'll add 1 to that exponent. So add 1 to that, you get a plus 1/2. Now divide by the 1/2, that's the same as multiplying by 2, right? So that's going to put a 2 right there, since we'd have 1 times 2. So there's another antiderivative for you. Aren't these fun? Yeah. Let's see, find f. If f prime is e to the x plus 20 times 1 plus x squared to the negative 1, and f of 0 happens to be negative 2. Okay, so what do we get if we do that? So the e to the x, what's the derivative? What function gives you the derivative e to the x? Okay. So f of x, well, e to the x, remember, is its own derivative. That's the easiest one ever, right? And now we've got to deal with this other piece over here. Okay, so let me just write it a little bit different way before 1 plus x squared. It looks like this, okay? Now, dx plus 20 times 1 plus x squared. So that's f of x, right? Written just slightly differently. And I want to bring this up because this part, there's some tables in the book and stuff that you can look at. But this is the antiderivative for tangent inverse of x. Okay? So the derivative of tangent inverse of x is equal to 1 over 1 plus x squared. Okay? There is a table in the back of the book that will help you with a lot of this stuff in the appendix, the integration tables. Okay, so those are going to be real handy if you print them out, bookmark them, something like that. They will definitely help a whole lot because you're going to start coming across questions where you might want to look them up. Let me see if I can pull that up real quick. Okay, so in your book, if you go to the ebook, go down to the reference pages, okay? Click on reference pages, and Lord, I don't know which reference page it is, so let's see, reference page 1. Look, here's just a whole bunch of other little things, bunch of trigonometry stuff back here that you might want to know about. Okay, so here's reference page 5, has lots of different differentiation rules. So you could use those. And look, if you look at tangent inverse right here, we have that 1 over 1 plus x squared. So you can scroll through looking for it like that. Or you get to these table of integrals, and that's what this little symbol means. And we'll get to that in the next section, okay? But you could go down and look, and these are kind of weird to use. So you know what, let me get a little screenshot so I can kind of place it, and we can make notes on the other stuff. So on that table, where'd you go? Oh, great. I don't know what I'm doing now. I'm just messing all kinds of stuff up. But anyway, on this table, what you have to do is you have to look and pay attention. Remember, the du is just, in all these tables, the u is the variable, okay? So they're not using x's and stuff, they're using u's. Any a, b, c, or whatever you see are constants. So when I'm matching this up, on this table, a is equal to 1. Okay. U is just the x. And then remember du, that's just 1 in the top. So if I'm looking at this formula, I'm looking at 1 squared plus x squared, which is just 1 over 1 plus x squared, right? So then my antiderivative for that part is 1 over 1 times tangent inverse of x over 1. Of course, that simplifies to tangent inverse of x. So on the tables, you can use those. It's really handy to learn how to use it, okay? But you do have to be careful playing the matching game and stuff like that. The big key for me is always to remember that u is the variable, but it says so in the du, right? And the rest of them are some constants, and you just kind of have to make a substitution. So my antiderivative then, these were supposed to have primes there. So my f of x is just e to the x plus 20 times the tangent inverse of x. Now, it does say, man, this page has gotten messy, that f of 0 is supposed to be negative 2. So what that means is that we have this plus c at the end. If we know what some value is for the function, okay, then we can always substitute that in and solve for the constant. So I know f of 0 is supposed to be negative 2. So negative 2 is going to be e to the 0 plus 20 times tangent inverse of 0. So tangent inverse of 0 is just going to be 0 plus c. So we get negative 2 equals 1 plus 0 plus c. So negative 3 is equal to our constant. So we actually have a specific function here, not just a general antiderivative, but a very specific one, because it gave us an ordered pair that it was supposed to satisfy. So there is our antiderivative. So as long as you remember your basic differentiation rules and stuff like that, shouldn't be horribly awful, but those integration tables come in really super handy. So I really strongly suggest making sure you kind of use those if needed. All right, so we're going to continue more. This is just kind of an introduction to antiderivative stuff. We're going to get much more involved in it starting in Chapter 5. So have a wonderful evening.